Dear students and the participants on the course on railway engineering, now in today's discussion, we are going to talk about the various types of stations, the yards and the level crossings which are provided on the tracks. If you remember, in the previous lecture, we talked about the train control systems, and the two or the main train control systems which we have discussed were the automatic block system and the centralized train control system. Then the improvements about that in terms of automatic train control, absolute permissive block systems and moving block systems were discussed. And finally, towards the end, we discussed about the non-block train movements which have been in use under the specific conditions. Now, in this lecture, we are changing our discussion from the train controls to some other aspects related to the track and more specifically very near to the stations in terms of the stations and yards or the level crossings which can appear on any particular location along the track. Starting with the stations, the purpose of providing the stations is what? You must have traveled by the train, you must have gone to the station, you have taken a train from a platform, you have boarded it from there or you have alighted from the train. So, you must have seen that what are the various type of facilities which have been provided on that station. Considering all of those things, these purposes can be identified. So, what are the purposes? First of all, it controls the movement of the trains. So, how the train is to be received, how and when the train has to be dispatched. There may be a possibility that two tracks are crossing each other, there is a merging of the tracks or diverging of the tracks. So, the trains may be crossing, that also needs to be controlled, or the trains which are moving at different speeds. In those particular scenario, if there is a faster train, then the opportunity has to be given to that faster train to cross the slower train, and that is going to happen most of the times at the station where the number of tracks or the lines are being provided. It also allows for the passenger and the goods movement with respect to the different locations by using the trains which are available at those stations. It provides facilities for the en route passengers. You are traveling in a train, you need water, you need food, you need something else. So, if the station is not there, train is continuously moving from point A to point B for 10 hours, then the things are going to be very difficult. So, certain facilities needs to be provided to the passengers and they may be available at the station and the passengers can enjoy those at that station. It enables the sorting of the trains as well as the wagons by using the sidings, and the sidings becomes a part of the yards, and that is where we will be talking about the yards. It provides maintenance facilities for the rolling stock, especially at terminal stations or at junctions. It also facilitates the movement or the changeover of the train crew. So, the train crew is going to be there with the train for a certain hours. After that, the new people will come and take over the duties. So, that possibility is done at the station itself. Now, if we look at the classification of the stations, so one such classification can be an operational classification, and in terms of an operational classification, they are defined as block stations or the non-block stations. And within these block stations and non-block stations, again there can be the various classifications. Say in the case of block stations, there are A, B and C class of stations, whereas in the case of a non-block stations, there is a class D. Now, in the case of these block stations, the driver or the loco pilot need an authority to proceed and enter the block sections. In the case of non-block stations, the stopping places are between two consecutive block stations. There can be a special class where approval from the Commissioner of Railway Safety needs to be taken, in short defined as CRS. Now, in the case of A class stations, at these stations the lines shall not be considered clear and a line clear shall not be given unless. Now, we know many of the points with respect to this line clear aspect. We have been talking about this when we started discussing about the interlocking systems and the train control systems. So, few of the things again will appear here. What it says, the whole of the last preceding train has arrived completely, and that is where the detection, the last vehicle detection or device was talked. All signals have been put back on position behind the said train. That means the train now cannot come from the back unless this train has moved by a certain distance or the blocks. The line on which it is intended to receive the incoming train is clear up to the starter signal. So, up to that particular location everything is clear, there is no obstruction, then only the line clear can be given. All points have been correctly set, all facing points have been locked, and the train can be taken on that particular line on which these points are being set or they have been locked. Now, where the line clear cannot be given for a train unless the line on which it is intended to receive the train is clear for at least 400 meters beyond the home signal or up to the starter signal. So, there is a distance which is also coming into consideration here. What it says that it cannot be given for a train unless the line on which it is intended to receive the train is clear for at least 400 meters beyond the home signal. The home signal is here. So, if this is a station, then the home signal is here. So, beyond this home signal up to 400 meters the line clear conditions are there, then this train can be taken in, it can come to this location and then afterwards whatever the dispatch conditions are there can be taken. Then signals which are used in the case of A class stations are Warner signals, home signals, starter and advanced starter. That means you have Warner here and then there is a starter signal and there is a advanced starter signal. In the case of B class stations, now condition for line clear in the case of double line, whole of the last preceding train has arrived completely. All necessary signals have been put back to on position behind the said train and the line is clear at stations equipped with MAS multi-aspect signaling systems up to the outermost facing points or the BSLB if any. So, with respect to the outermost facing point or BSLB if used, if it is there, with respect to that the distance is being taken and accordingly line clear signals are being given. Again we have discussed already this particular aspect. In the case of single line, this always remains there that the whole of the last preceding train has arrived completely. All necessary signals have been put back to on position behind the said train and the line is clear up to SLB. SLB is the shunt limit board or advanced starter if any at the end of the station nearest to the expected train or up to the outermost facing points if there is no SLB or advanced starter. So, there are two conditions which have been talked with or without SLB. So, accordingly then line clear conditions are going to be defined. For C class stations, here for the single or the double line cases, the line clear is given that the whole of the last preceding train has passed completely at least 400 meters beyond the home signal and is continuing its journey. So, it has already gone beyond and then only the line clear is given. In the previous case we were saying that we can give it a line clear if from the home signal beyond that 400 meters are clear, then we can allow. Here we are saying that it has already gone beyond 400 meters. The signals taken off for the preceding train have been put back on position behind the said train. It is normal practice, provided that on a single line the line is also clear of trains running in the opposite direction towards the block hut from the block station at the other end. So here you can see the different type of station aspects and the type of signals which are provided have been shown. Say in the class A station, so there is a warner, home signal, starter and advance starter, that is what we discussed. So when the train is coming from this direction, then if it is being set to be taken on the loop line, so it will come here. Here again, as you can see that the isolation conditions are also being shown. So this is a case of a double line system, it is a single line system, then for that single line warner and then home, then it is defining whether it is going to be taken on the main line or it is going to be taken on the loop line, and in that loop line again the starter signal is being provided here. When you talk about the class B stations, for a double line system, the outer warner, home, starter, advance starter, they are again in the same position. There is a possibility of movement here which is being shown. That means from one main line to the other main line also the train can move, and the loop lines are also being set. So this is a beyond here, this is a block section, and then in between there is a station section. In the case of a single line track, so again outer warner, home, starter and advance starter. Along with that there can be a shunting limit board, that is SLB. So that can also be there as it is being shown here. And on the basis of again the loops which have been taken, so that the trains can be taken to side and the main line is available for the through movement of the trains or the faster trains to overtake the slower trains. So these loop lines are there and accordingly the starter are being provided on that also. Now this is a class C station condition where warner, home are being provided, and then this is the overall block section which is being used. So that is again the same in the case of a single line. Now here a comparison of the stations is being discussed. So comparison of a class A and a class B stations. This class A, it exists only in TAS, that is two aspect signaling systems, whereas in the class B it exists in two aspect signaling systems as well as the multi aspect signaling systems. Class A has now slowly they have become obsolete and they are being taken out, and most of the stations they have been converted into the class B stations. There is no station section, but here a definite station section is there in the case of class B. There is no shunting after the line clear is being given, but in the case of class B the shunting is possible. Then this line clear cannot be given to both sides simultaneously, whereas in the case of a class B there is no such restriction. There are two trains which are standing, one going north, other going south, and they can proceed. Then the line clear cannot be given unless the reception line is clear, whereas again in the case of class B there is no such restriction. So on the basis of this you can very easily make out that as we have moved from absolute systems or the key based systems to the more modernized systems, the computerized systems, centralized system, automatic train control systems, these all aspects fits in well with those type of systems, and that is where the utility of the class B types of stations has increased and most of the things have been converted to that. Then obstruction is protected by two signals. Here in this case of a class B it is being protected by a single signal. Now let us look at the non-block type of stations. One is known as halt. This is the simplest form with same shelter for booking of tickets and waiting, and platform is at the rail level. So it is just at the ground level station, a very small hut type of structure may be there from where the tickets can be given, and just in front of that some small waiting area can be created. So this halt is basically for those particular locations where there is not much of the passenger traffic which is going to use the train, and the train may be stopping here maybe for a minute or maximum 2 minutes. Then flag stations, these are provided with a station building. There is a staff also being appointed here for different works. It is equipped with a Morse telegraph or a control phone for communication with the nearby stations so as to set and see whether the lines can be given clear for the movement of the trains. Then wayside or the crossing stations, it is a more generalized form of the stations which is there. Here the basic idea is to allow the crossing of the trains, especially on single lines, or the mail or express trains stop at the major stations. In those cases also this can help a lot. It deals with the parcel traffic only. The points and the switches are controlled by one cabin or two cabins either on each side, and it performs the reception and departure of the train. So, here we can see that these wayside crossing stations are being shown. So, this is for a single main line system where is a one passenger platform being given here, and here because there is another line which is coming on the other side. So, the name of this platform is a island platform, and these platforms they are being connected by the footover bridge so that the people can move from one side to the other side. So, there is a main station on this. So, the people will be coming from this side, will be having a ticketing facilities or waiting facilities here, and then they can move to the island platform depending on that in which particular direction train they are going to take. Here this is double line system. So, you have an up and a down track, and then with respect to that the loop lines are provided. So, there is an up loop line and there is a down loop line, and the platforms are again being aligned with respect to that. It means within the main line no such platform has been provided, and if there is a train which is coming and has not to stop here, it is a fast train, then it can use these main lines for its movement and will go straight. So, it becomes a run through line. Junction station, these are the stations with 3 or more lines which are merging or diverging from or in the different directions. Say here this is a single line main line track, and from there now the line is coming out to the loop lines, and from their loop lines then here you can see that there is a platform which is ending at the building itself, and then this line goes here. Similarly, on the other side, say as you can see that there is a branch line which is coming. So, at such stations where these type of lines are coming and they are meeting, they are being defined as a junction station. And the another one where the two lines are being shown, that is up and down are being shown. Then here also the use of island platforms in being done, and then on the basis of that we have the lines being provided, the sidings being provided. So, sidings again can be for the passenger traffic and for the goods traffic. So, if it is a good traffic, it has to be taken further away because there will be loading and unloading of the material, will take lot of time. A whole of the train or a part of the train has to be loaded or unloaded. So, here the passenger train will be walking, and then there can be a branch line. So, the train which comes from here has gone into the loop and then goes to the branch line, or if it is not a requirement, then it can even come back to the down line. The same way it can happen on the other side. So, it all depends how many such lines are coming. Accordingly, those type of facilities will be provided. Then the terminal stations. Now, terminal stations are the stations where everything just terminates, the line comes to the end. So, just stops here. So, here the line or a branch line terminates. The station is equipped with facilities for passengers, wagons, locomotives. So, you can see that this track 1, track 2, the train will come here and then the train will stop here. The platform has been provided, people will come through this platform and then they will exit, or they are coming from outside, they enters here, and depending on which particular platform their train is, they will move to those particular platforms. So, in general you will not find the foot over bridges being provided in these type of systems. Another thing is that on this track when the train comes and the locomotive comes here at this dead end, now if this locomotive is to be utilized for other reason, sometimes an arrangement is provided here in this form, and using this arrangement this locomotive is detached and then it will come through this particular track and will go out. But in most of the cases, as soon as a train has come here, it is terminated, all of the people have come out, then within no time this train is taken back to the yard. So, this line becomes available for the reception or the dispatch of another train. Now, let us start discussing about the yards. So, there can be different type of yards. Say the first one is a coaching yard. As the name suggests, it deals with the reception and dispatch of the passenger trains, and accordingly the related facilities are going to be provided in this yard. So, reception and dispatch of the passenger trains. So, it is trying to create the trains of the train has come, then the wagons have been taken out, and they can be utilized to form another train also. So, that is a type of a yard it is, and accordingly for these wagons, for their upkeep, the facilities needs to be provided. Goods yard, this deals with the reception, stabling, loading, unloading and dispatch of the goods wagon. So, the train comes there, it is a goods train, it is being loaded with the material, so it is being received, then the loading is being done, or if there is a requirement, an unloading is being done, and finally the whole of the train is being dispatched. So, as we have seen in one of the diagram, that goods platform was taken at the farthest point. And here in this case, when you are talking about the goods yard, so whole of the train which has come, which is being loaded or unloading or received and dispatched, there is no sorting of the wagons. So, we are not taking out the wagons and we are not adding the wagons in this case, so as to create a train. And marshalling and reforming is also not done in this case. Separate goods sidings are usually provided because it takes lot of time, and it may interfere with the receptions and dispatches of their passenger trains, which may be taking lesser time. Locomotive yard, from the name itself again, this is more specifically dedicated to the locomotives. So, that means whatever locomotives they are in use for taking the trains, or now they have available ideally because they are not taking the train now. So, in those cases they will come to this particular yard and they needs to be examined, checked with respect to their usability further. So, whatever facilities which are required for doing those testings, those facilities will be available in this locomotive yards. And the space is decided on the basis of the number of locomotives which are going to be handled together. So, based on that, 3 lanes, 4 lines, or the length of the lines which are going to be provided for those locomotives needs to be decided. Then sick line yard, again the name itself defines, this deals with the wagons which are declared defective, or the repair related facilities or the workshops, they are provided in this particular yard, so that these wagons they can be brought back to the normal conditions and then can be reused while forming their trains and dispatching the trains. One important one is known as a marshalling yard. Now, this is a yard where goods trains are received, sorted, new trains are formed and dispatched. So, everything is being done. So, the train comes, so it is being received, then there is going to be sorting. Sorting means that if we have to make a new train, so we are sorting the wagons out, and we may be making the box end type of a wagon train, or it is a flatbed wagon train. So, depending on what are the requirements, that sorting is going to happen, and then the new trains are being formed, and once those new trains are formed, then these are dispatched. So, there may be different such sidings on which these type of works can be done. It deals with the loaded and unloaded wagons on trains. Marshalling is done in such a way that the wagons can be conveniently detached without much shunting en route at the wayside stations. Okay, so that's way the arrangements are usually done. So, as we said that there are these 3 functions of a marshalling yard. It receives the trains, it allows the sorting of the trains, and then finally the dispatch is going to be there. So, what are the principles of the design of these marshalling yards? The train should be received and dispatched as quickly as possible. the size of the marshalling yard, the number of sidings which needs to be provided for doing different type of activities, they needs to be taken into consideration while deciding that how quickly all of these things can be done. Directional movement of the wagons shall be unidirectional. It should not happen that in all of the sidings the trains are moving in both the directions. So, there will be a unidirectional movement. There shall be no conflicting movement of the wagons and engines. Obviously, when we are talking about a unidirectional, so many of those conflicting conditions are removed, but at the same time, if there is a possibility of changeover from one particular track to the another side, so these also are usually reduced because it is going to work in the form of the number of sidings which comes in this way. So, those sidings are going to take care of different operations, and then finally again it may happen that they may merge, and whatever is train is ready, that can allow to be moved forward. The lead for movement of wagons and trains should be as short as possible. That means the distance we are talking here. It should be well lighted, and scope should be there for further expansion based on the traffic density which is increasing. Now, what are the various types of the marshalling yards? So, first is the flat yard. In the case of flat yard, all tracks are laid almost at level and the wagons are relocated using the engines. It requires frequent shunting and takes more time during the back and forth operations. So, when the shunting is happening, you are going forward, you are coming backward, coming from one track to the another track. So, that is going to take time. So, here in this particular yard, so a possibility of delays is going to be there. Now, this type of a yard can be adopted when there is a limitation of the space or the severe limitation of the funds or the number of wagons which are to be dealt, they are less in number. The another type of yard is known as the gravitational yard. Word itself also defines that how this yard is functioning, or the wagons which are coming in this yard, they are moving. So, they are basically moving under the gravitational force, and that gravitational force is going to be induced by way of the provision of a gradient. So, there are some tracks which are laid at a gradient. The wagons moves to sidings for sorting under the action of the gravity, and engine assistance is required only in some of the operations, not all the operations, as it says that here using this gradient, as soon as it comes on that, then wagon will start moving by itself on that. But yes, for stopping arrangements are being done, and those stopping arrangements can be done with the help of the gradients again. Then hump yard. The hump yard is provided, then the wagons are pushed to the hump by an engine. So, it is something like this. So, this is a hump. So, for this movement the engines are going to be utilized, but then after that using the gradients which are provided, those wagons will start moving down and they slide to the sidings under the gravity. So, in this case is a engine push, and here it is a gravity effect. Topography of the location plays an important role in this particular type of design. If it is an undulating system, then very easily we can create a hump there, otherwise it has to be created artificially. Now, the various gradients which are adopted, those gradients are adopted for two types of yards. One is a mechanical yard, another is a non-mechanical yard. So, rising gradient of approach is 1 in 50 to 1 in 125 in the case of mechanical, and it is 1 in 50 to 1 in 100 in the case of non-mechanical yard. Still a bit steeper condition here. The hump in both of the cases, it remains level at the top. Then first falling grade. So, the first falling grade as being shown here, this is the first or a second or a third or a subsequent falling grade. So, the first falling grade after the apex of the hump is 1 in 17 to 1 in 20, a steeper value. This is a bit flatter in the case of non-mechanical yard. So, it is 1 in 25 to 1 in 35. For intermediate grade, up to the point where the train starts, it is 1 in 50 to 1 in 60, but in the case of non-mechanical, it is 1 in 80 to 1 in 200. Now, what is this mechanical yard or what is this non-mechanical yard? In the case of mechanical yards, actually the retarders are used which are provided on the track, and these retarders control the speed of the wagon when the wagon is going under gravity on those gradients. And with the help of the resistance which is being offered by these retarders, finally it is going to be stopped at a specified location. But in the case of non-mechanical yard, these retarders are not being provided. There are brakes which are provided on the wagons, and utilizing those brakes and the people who are there on the wagons, slowly the wagons are brought to a stop condition. Then the final falling gradient up to the clearance of the points, it is 1 in 200 to the level condition, where it is 1 in 80 to 1 in 200 in the case of a non-mechanical yard. The gradients of sidings, down gradient eased off and then an up gradient given to stop the wagons at the end, because they are coming under those retarders, the resistance is being provided, so they are coming under gravity, and finally we are trying to provide a level and an up gradient in this form. So, that is why they can stop there. Here in the case of non-mechanical, a falling gradient of 1 in 400 or 1 in 600, a very flatter condition is provided, and here the brakes are being applied. So, it is easier to stop in this case. So, here you can see the layout of a marshalling yard. So, the train may be coming from here, that is a down line. From this down line it is being received. So, down reception is there. Say a hump is provided at this location, then under the gravity it is going to the sorting one. So, there are two such settings which can be possible. Then it comes to the down departure, and from there it finally comes back on the down main line. And the same thing can happen on the other side. Now, this is a case where for the down line and the main line, the separate such marshalling yard is being provided. But if there is a requirement, there is a problem of a space, then both of the lines can have these marshalling yards at one location. That is what is being shown here. So, even from the main line for a down and up movements, the trains they have been taken to one side only, and then there is a reception, sorting and departure conditions being set there. Here this diagram, what we can see is the gradients which are being provided in the mechanized hump yard. We have already talked about the various types of gradients. Here this is an engine push, and on the other side there is a movement under gravity, and because it is a mechanized system, the retarders will be available. So, the initial one is a more steeper, then less steeper, and that is how finally a further lesser steeper condition is being provided here. A few other salient features related to the marshalling yards. The spacing 400 kilometers if lead is 500 kilometer and the train section is 100 kilometers. Length of the sidings 700 meters for the broad gauge tracks. Number of sidings, these are based on the 3 to 4 trains per siding. Then shunting neck, the longer than the longest train. So, that much one train should get into that neck. So, that shunting is happening after that. Then average height of the ordinary hump is 2.5 to 3 meters. Average height of the mechanized hump is 3.5 to 6 meters. Average gradient from hump to the end of the switching zone is 2% for empty and 1.5% for the loaded wagons. Now, let us discuss about the level crossings. Now, level crossings are required whenever a situation like this appears, where a track is going and then a road is crossing the track and there is a lot of traffic which is moving on this, and if the train comes on the track, there is always a possibility of having a eventual condition or hazardous condition occurring at this particular point of intersection. So, when the road traffic crosses the rail traffic at the same level, it is defined as a level crossing. At the level crossing, the road is brought up to the level of the rail table. So, the rail table means whatever is the level of the height of the rail, Up to that particular level, the road is being brought. And the guardrails are provided to ensure the clearance for wheel flanges. So, here you can see the guardrail has been provided here, and this guardrail which is provided on this side, it helps in the movement of the flanges and protecting them. Then these level crossings, they become necessary because the alternative of providing over or under bridges is very costly affair, but of course this under or over bridges needs to be provided depending on the intensity in terms of the number of trains which are moving on the track as well as the number of vehicles which are moving on the road. The level crossing will have an arrangement to stop the road traffic on either side. Except the D class crossing, in all of the crossings there is going to be an arrangement for that, and this arrangement can be in different forms. The arrangement can be in the form of a swing gate, that means a gate which is just swinging like this, or there is a lifting barrier which means it goes up, so that is a lifting barrier, or there can be a chain which can be used across the road. So, the chain is being fit as soon as the train has gone, it is being opened now. So, the road is being opened for the traffic, the chain is removed. It will act check rails to keep the flange way clear. We already talked about that in the previous diagram. The provision of warning signs are mandatory on either side of the level crossing for warning the road user. So, as you can see here, stop. Stop. This is a one sort of a warning sign which is being placed here, which says to the road traffic that you have to stop. There is a train which is going to arrive at this location. The classification of the level crossing, it is made after conducting the level crossing census of TVU, and this is being done for the 7 days once in 3 years, and based on that the average per day is being used. So, every 3 years the census is to be done for the number of trains which are moving here, for the number of vehicles which are crossing on this particular location. Based on that, the TVU will be, total vehicle unit will be calculated. So, when the census is being done, it has to be done for continuously 7 days, and then from those 7 days the average is to be computed. So, as I said, the classification is based on the nature of road. That means we can talk about the various classification of roads here, we know about that. In the case of rural highways, like we have national highways, state highways, MDR, ODR, VR, or similarly in urban roads also different classifications are available. Then the another thing is the number of road vehicles which are passing and the number of trains which are passing. So, what is this TVU, the train vehicle unit? This train vehicle unit is the number of trains multiplied by the number of road vehicles, and this has been taken for 24 hours. And when we are considering this number of road vehicles, then certain units are being given which can be used to convert those vehicles to a one particular category, the same way as we do in the case of road traffic where the passenger car unit is there. So, here for train, motor vehicle, bullock carts and tongas, the value is 1. For cycle rickshaw and auto rickshaw, the value is half, and for the motorized two wheelers, the value is being taken as 0.25. Now, if this TVU is over 20,000, then it qualifies for the interlocking. That means the interlocking has to be provided as soon as the TVU is 20,000 or more, and as soon as this interlocking is done, that means this level crossing is going to function with respect to the setting of the points and the signals automatically. The minimum TVU for the ROB or RUB, the rail overbridge or underbridge, on the cost sharing basis it should be 1 lakh. So, if it is 1 lakh, then this can be thought of, with relaxation on the suburban sections. And this cost sharing basis means that cost is being shared between the railways and the road authorities. Here the classifications are being given. If it is a special class, then the TVU is greater than 50,000. If it is A class, then it is between 50,000 and 30,000, or the line capacity utilization is 80% on a single line, or the number of road vehicles is greater than 1000. In the case of B class, the range is 20,000 to 30,000, and within this 20,000 to 30,000 we have two categories as B1 and B2. So, in the case of B1 it is 30,000 and 25,000, in the case of B2 it is 20,000 and 35,000, and this 20,000 we have already discussed. As soon as this value is there, the interlocking has to be provided. The another criteria here is in terms of the number of road vehicles. If the number of road vehicles are greater than 750, then also this is a B class categorization. The last one is the C class. This is all other level crossings for roads not covered under the above classes. Then another thing is that if the TVU is more than 6,000 or the level crossing visibility is poor, in that case the unmanned crossing has to be converted into a manned crossing. And this manned crossing, when we are talking here, it may not be controlled automatically. For that reason we have already said that 20,000 is the value. Then the road and railway line should cross preferably at right angles. Angle of crossing, it should not be less than 45 degrees. All interlocked level crossings, these should be kept normally open to the road traffic. Only when the train is going to arrive, they are closed. In case of a non-interlocked level crossing, the gates must be kept closed. Now it is an opposite situation if it is interlocking is not being done. And they can be kept open during the busy seasons with the proper permission. So, in the busy season a lot of traffic is there. If you keep it closed, big queues will get created on either side of it. In those situations, then permission can be taken to open it during the busy time. Then height gauges are also provided at these locations, so that the type of vehicles which are crossing here can be controlled. So, they are located at a minimum 8 meters from the gate post in the case of electrified sections. These level crossings, they should not fall within the breathing length of the LWR. When we discussed the LWR, the long welded rails, at that time also we have talked about the breathing length, and we have also talked about the level crossings which should not come in those particular lengths. Then rail joints, they should be avoided in check rails and on the running lays within the level crossing and 3 meter on either side of the end of the level crossing. So, if this level crossing is being provided, so in this particular case, in this area, that is what we are talking, the rail joints should not be there, and they should not be there up to a distance of 3 meters on either side. So, that is the distance which we are considering. In case of the LWR, avoiding the fish plated joint on the level crossing and within 6 meter from the end of the level crossing, that means in this case this distance increases to 6 meters here, and fish plated joints should not be there in those areas. When we are talking about the high quality of the road network, in that case it is better that instead of providing a level crossing, that means at grade system, we should have a grade separated system. So, the road can go from the top. The visibility of the man gate shall be minimum 5 meters and the gate post shall be 3 meters from the center of the track. The fencing should be done 15 meter parallel to the track on either side. That means if we are talking about this as a road and this as a rail, then for a distance of 15 meter on either side, here and here, a fencing is to be done, so that people should not do some adventure here. They come and take the vehicle like this and come to the other side. So, for 15 meter on this side and 50 on that side, the fencing is to be done. So, here you can see the level crossings being provided with the chain condition, that is the back side of this post where it is written stop. So, indication is being given, you have to stop here, and at this back how this chain is being attached, this is how being shown here. So, here at the center the stop post is there, on this side the chain is being fixed, whereas on the other side it is being put in a hook. When it is to be opened, then it will be taken out of the hook and it will be taken from this side and it will be taken to the one side of the track. So, this is how this system is working. Various other specifications are also being shown on this slide. Then the combination of the lights are also being talked here. So, there are four such signals: the distant signal, the gate come distant, home signals. So, combination of these, when we are looking, if the distant is yellow, gate come distant is red, in that it says stop at the gate signal. If the distant is green, gate come distant is yellow and the home is red, then it is stop at the home signal. If it is green for distant, double yellow for the gate come distant, and home is yellow or yellow with route, then it means it is going to be received on the main line or the loop line, depending on which particular route is being set. And if all are greens, then the train is actually on the run through line, or it is on the main line and is going to continuously travel. So, the locations of these signals are being shown here with the various distances, the overlaps. As you can see, the overlap of 180 meters here, distance of the distant signal from the stop signals are being shown. Then the this board is also there, which is at 1.4 kilometer. So, this is for a passenger train board. So, those are the arrangements which should be there when we are very near on a level crossing. So, with this we close our discussion now. So, today we talked about the block and the non-block stations, their salient features. Then we discussed about the various types of the station yards, and then more emphasis has been given in that discussion to the marshalling yards and different elements which can be there. And finally, we discussed the level crossings, their classifications on the basis of TVU, and various important features associated with the level crossings. With this, we close it. Thank you. We will be meeting in the next lecture.